So I think this is the first screen, right? Any other question?
Sir, can you quickly revise the previous topic because we missed the class almost half of the class.
Oh, is it?
Yeah, it's specific heat capacity.
How many of you were not present in the last class? Raise your hands. ठीक है चलो तो ये ज्यादा डिफिकल्ट था समझने के लिए वो इजी है ठीक है तो वो हो जाएगा ठीक है So first class में there was first topic is heat capacity. So heat capacity क्या है? Heat capacity of a substance is किसी भी substance को जब we heat it, its temperature changes, right? Okay. So heat capacity is defined as amount of heat required for unit rise of its temperature. ठीक है? मतलब समझो अगर किसी सब्सटेंस का टेम्परेचर वाज से रूम टेम्परेचर 25 डिग्री सेल्सियस, now its temperature became 30 degrees. When I heated it for some time, its new temperature is now 30 degrees. So what is the change in its temperature? 5 degrees Celsius. So whatever heat was observed, say Q heat was observed for 5 degree rise. So for 1 degree rise it will be Q by delta T. So 1 degree rise के लिए जो भी heat absorb होता है that is called heat capacity. ठीक है? अब this is not constant for a given substance. If the substance mass now I doubled, so now it will absorb double the amount of heat to rise by the same amount. है ना? So this is not a constant. So इसके लिए मैंने और एक चीज define किया specific heat capacity. Now what I am fixing the mass now. So specific heat capacity is the amount of heat absorbed by unit mass of the substance to raise its temperature by unit degree, right? So this is C dash. So this C is then defined as heat absorbed per unit mass for unit rise in temperature. Got it? Okay. So what will be now units here? Its SI unit is joule per Kelvin, and here it will be joule per kg per Kelvin because it is mass. So this is joule per kg per Kelvin. Understood? I am giving you mathematical definition. Okay. So what is the English statement? You just read through the book. Have you understood what this heat is? Okay. So now if I tell you that I heated a substance, right, and its temperature changed by delta T. So how much heat it has absorbed? So you will say it has absorbed Cm delta T. Because now this C is constant for a given substance. Because it is always for unit mass of the substance. Just like specific resistance is always for unit length and unit area of cross section. है ना? उसका dimension कुछ भी होने दो. So once I have defined the specific heat for a substance, it is always constant for that substance. So जो भी constant होता है उसका हमारे पास table होता है ना? So for example, there is a table given like this: specific heat of various substances. इसमें भी होगा थोड़ा volume में होगा volume ये रहे, ठीक है? So which substance has highest specific heat? Water. So it absorbs 4180 joule. 1 kg of water, when heated, it will absorb 4180 joules of heat energy to raise its temperature by only 1 degree Celsius. Okay? So that is the stress. So, which means what? It will take lot of time to become hot. Whereas, if I heat a lead substance, lead, its temperature will rise immediately. Just with 130 joule of heat, its temperature will change by 1 degree Celsius. Got it? So, there are some substances which will quickly rise in their temperature when heated, and some substances will take a lot of time to become heated. It's like this. If the heat capacity, if the learning capacity of student is fast, so with little bit of explanation he will grasp because his learning capacity is more, right? But in heating case, it is the other way around. Substance which has more heat capacity, its temperature, so it is taking more and more heat. It's like you're taking more and more knowledge, right? But then the understanding of the concept is less. So the rise in temperature is less that way. So it depends on the property of the substance, how their atoms are organized. That's why the specific heat for different material is different. It depends on their internal structure. Got it? Just like different students have different ability to grasp that way. Okay, na? So that's the internal property. Same teacher talking, but reception is different. Because some are more listening with more alertness. Some never are able to concentrate. Right? So it depends on internal factors. So likewise. So this is how the heat is calculated. You have to know the specific heat, which chart is available always. The change in temperature you can measure. Mass is a measured quantity, so you can calculate. Right? To measure temperature, we require thermometer, and this is how you measure heat. So this formula is used in calorimeter. Okay. Now, so you understood how to figure out how much heat will be absorbed when the substance undergoes this much change in temperature, right? So now in calorimeter, so to measure temperature, it can be directly measured with the thermometer, but heat cannot be measured directly. It has to be measured with the help of this formula, right? So what do we do in the calorimeter? We have a copper vessel in which we put, say, water and hot metal block. Two things. So it's a mixture of water and let us say some hot block of metal I put it. So what will happen after some time? And then I have a stirrer which I'll shake gently so that the hot metal block now will cool down. It will lose heat and the water will gain heat. So after some time the temperature of the water will rise and the temperature of the block will go down. I know what was the initial temperature of the water. I also know what was the initial temperature of the block. Now with the help of this thermometer, which is always in the calorimeter, I will measure the temperature of mixture after equilibrium. So at equilibrium, the water temperature, the metal block temperature will become same. Got it? है ना? When water के अंदर में I put a metal block which was at a higher temperature, after some time everybody will attain same temperature. That is the temperature of the mixture. Got it? So there are three temperatures involved. Now see. So this is the construction of calorimeter I explained. And during heat exchange, heat is only exchanged between the metal block and water. It's not going outside. We have ensured that by putting a calorimeter inside a heat insulated casing, which is a wooden jacket Then we filled it with some wool or cotton. So no heat will escape outside the copper vessel. Okay. And from top also we have fixed wooden packing. So there is no heat escaping into the surrounding. So all the heat from the metal block is going into water. Okay. So then what happens? So what is the principle of calorimeter? So calorimeter is used for heat measurement. Okay. So therefore, suppose I have this calorimeter. I have water. Let us say initial temperature of water was T1, and I put some hot metal block in it, and its initial temperature was T2. After some time, right? So I have a stirrer which I am like shaking, and I have a thermometer to note down the final temperature. So this thermometer will note down temperature T, right? Okay, so we have got three temperatures. So this is losing heat into the water. So this is heat lost. Whatever is the heat lost, the same heat is gained by water. So in calorimeter, what is the principle of calorimeter? Of calorimeter, it is also called or method of mixture. Mixtures. States that when no heat is lost to the surrounding, right? Then heat lost by hot substance is equal to heat gained by cold substance. Okay, so when no heat is lost in the surrounding, which we have ensured by keeping the calorimeter inside a wooden enclosure or wooden jacket, and from top also we have covered it with wood. So wood is a bad conductor of heat. Okay, and the space between the vessel and the wooden jacket we have filled it with again heat insulating material such as cotton or wool. So this is just to ensure that heat exchange remains between the metal block and water. Okay. So heat lost by hot substance. What is the hot substance? This metal block. Let us say the specific heat of metal block is C1. Its mass is M1, and it has gone temperature change delta T1. So this must be equal to C2, M2 and delta T. Correct? Because this is how the heat exchange formula will apply. Whatever heat is lost, the same heat is gained. But specific heat of the substances involved are different. Their masses could be different, and the rise in temperature could be different. Right? So this guy lost the heat, so its initial temperature must be higher, right? Oh, मैंने ब्लॉक को 1 कर दिया, इसको चलो 1 कर देते हैं, इसको 2 कर देते हैं, वाटर को 2 कर देते हैं, ठीक है? Now this formula is applicable. So T1 is greater than T2. hot substance. ठीक है? So mixture temperature, obviously it is losing heat, so its temperature will come down. So what will be delta T? It will be T1 minus T. So T is the temperature of mixture. So final temperature of mixture. So what will be delta T here? This will be C2, M2 and now mixture temperature is greater than initial temperature of water because water gained heat. Correct? This is the difference T minus T2. Okay? So T1 is initial temperature of metal block. T2 is initial temperature of water.
So it will be C1 M1, right?
M1.
M1.
M1, correct. C1 M1. Yes, you're right. Okay. Now in this, we assume that no heat is lost to the surrounding. Now the calorimeter vessel, the copper vessel also is the surrounding, right? So here we have ignored whatever is the heat absorbed by the copper vessel. So if we take into consideration the heat absorbed by copper vessel, then one more term will be added here for copper vessel. So it will be C3, M3, T minus T2, right? No, T2, same. What is the initial temperature of copper vessel? Same as water. Water was filled in copper vessel. Okay? So now, if and copper vessel. Okay? So the mixture temperature, final temperature is same for everything. But initial temperature of water and copper vessel will be same. Okay? So if heat absorbed by copper vessel is taken into account, then so we have to add one more term for copper vessel. So it will be Cm M1 T1 minus T is equal to C2 M2 T minus T2 plus C3 M3 T minus T2. So in the next step, you can write one more step by taking T minus T2 common. Clear? So this is your principle of calorimeter, which will be used in solving numericals. So in the first chapter, all the numericals are on this formula. Okay? So these are the formulas for solving numerical. One is this, other principle of calorimeter, and these are the other formulas. So here, what is the relation between specific heat and heat capacity? So specific heat, so Q by delta T is heat capacity. So it is heat capacity divided by M. So heat capacity is also given as specific heat capacity times the mass of the substance. Okay, no? Just the play of little bit of shuffling here and there. Okay? So I will write the relation between, so therefore C dash is equal to C into M. Agree? Because if I multiply M here, it becomes Q by delta T. So C dash is equal to specific heat into mass of the substance. Specific heat to constant. The heat capacity is that. Alright, let's do some numericals. We have 20 minutes. There are some consequences of specific heat and all. You just read yourself. The mathematics part I've done. Rest is theory. You see the video. It's available. Video is not there. अच्छा ठीक है पढ़ लेना next class में clear कर देंगे अगर नहीं समझ आया ठीक है. Right now let us do some numericals. So first numerical is, so in my book it is by imparting heat to a body. Is it there? Its temperature rises by 15 degrees. What is the corresponding rise in temperature on Kelvin scale? Rise is same. So this is a easy question. Now there is one more relation I'll have to give you. So write down two relations. Relation between Kelvin, calorie and joule. 1 calorie is equal to 4.2 joules. Okay, this is one relation. Another is, therefore 1 kilocalorie will be 4200 joules. The second is temperature on Kelvin scale, that is absolute temperature, is equal to temperature on Celsius scale plus 273. So this is the temperature on Kelvin scale, this is the temperature on Celsius scale. To convert temperature from Celsius to Kelvin, just add 273. To convert temperature from absolute scale to Celsius, just subtract 273. There is one more thing is, the difference on Kelvin and delta T or Celsius is same. Rise in temperature when a substance is heated, okay? So the rise in temperature on both the scale is same only. It does not change, okay? So once you know this, that is change in temperatures on Kelvin, which is also called absolute scale, Kelvin scale and Celsius scale is same. Okay, so what was question 1? The question is, by imparting heat to a body, its temperature rises by 15 degrees Celsius. So delta T given is 15 degrees Celsius. So what is the corresponding rise in temperature on Kelvin scale? So this means is also equal to 15 Kelvin. This answer. It comes from Kelvin. Okay, everybody understood? Question number 2. So there are two parts, A and B. Right? Is it the same question in your book also? Calculate the heat capacity of copper vessel. Huh? So do that. So you have the formula on the board. Heat capacity, this formula. Then what do you have to do? So do it. Find the answer if you are getting it. So you have both mass and specific heat given to you, right? So since equal to C into M. What is the specific heat capacity given? 410. And what is the mass given? 150 grams. So this will be 0.15 kg. Okay? So you have to convert it in SI units. So how much is this? Calculate. So 15 months of 15. 15 goes up 61. Right? So how much is this?
61.5.
61.5. And what is the unit? Unit is joule per Kelvin. So remember the unit from basic definition. Heat absorbed per unit rising temperature. So this is part A. What do you have to do in part B?
You have to find Q, heat energy.
So heat energy when the temperature rises from 25 to 35. So you see here. So you have calculated the heat capacity, right? And you have to find Q. You are given the rise in temperature. So Q is also is equal to into delta T. Okay. So you use 61.5 into what is the delta T? 35 minus 25. So this is 10, right? 615. How much? This is because Q is energy. Right? Now do question 5, which goes 1300 joule of heat energy supplied to raise the temperature of 0.5 K. So first finish this and then finish it. Question 5 is same in your textbook. 1500. Sorry, 1300 joule of heat energy. It's question 5 only? Yeah. Okay. Do that. Let me see how many of you are able to attempt. So how are you finding this chapter now? Easy, right? Some 4-5 formulas. That's it. Feel free to ask for help. Okay? Try the step. Ask for help. Yes. You don't have Selena?
She has fever.
Asha. Otherwise, I can give you a note you like. I have not solved in the book, so mostly I solved 5. This have circle. I have my price petition. There's a wire in the book. You should return my book with the wire.
Yes, sir.
Completed?
Yes.
Huh?
Yes, sir.
Very good. Got the answer? All of you?
Yes, sir.
Okay. So what is the next circle question?
So 11.
11. Read the question. Is it the same as in my book?
200. Yes, sir.
Okay. Carry on.
11. 11.
Yes, how's it going? Can I just read the question once? So you have to use which formula? This.
Yes.
Okay? Because you are neglecting the heat taken by the container. Vessel is not absorbing any heat. So just this formula, first one.
Yes.
So identify the data, then calculate and convert the units to SI units. This one. So what you have to calculate here? What do you have to calculate?
Heat energy.
Heat energy.
How much energy will be required to increase it?
The final temperature.
Final temperature.
So you have to calculate T.
T.
T1, T2 identify correctly and then solve for T. Final temperature is the temperature of the mixture. Look here, what is it? Final temperature. What happened? Is the heat energy moving properly? क्या I can't समझ नहीं आ रहा.
She was asking. She was saying observing. She was asking what is today.
What is?
Today dinner.
What is today?
Dinner in your house. So she's asking.
अच्छा. अरे बाबा it's today's dinner. भूख लग गई इतनी ज़्यादा. What is today's dinner at your house? You don't know.
Yeah.
डिनर का याद आने से भूख लग गई. आंसर नहीं आया तो किसी को डिनर पर सबके घर में फोन करके बोल दूंगा खाना मत देना जब तक आंसर नहीं आ गया. ठीक है, डबल लगा. ठीक है, कितना आया? 38. Is that correct? Huh?
Yes.
Good. Okay. So how are you finding the questions? Next is, you still have 5 minutes. Next is question number 13. That's the last question. Question 13 में try करो. जिसका 11 हो गया. सबको आंसर आया 38?
Yes.
Very good. हो गया फिर तुम्हारा कल्याण हो गया. So answer for question 11 is 38. Everybody has got it, right? इसको नहीं है घर पे डिनर से पहले करना है. Next question is question number 13. Do it. Question 13. Last one. Everyone got it? 38? No, the last bench. किसी को नहीं आया ना? 38.
Sir, what was 1 kilowatt?
What was 1?
1 kilowatt.
1 kilowatt is 1000 watt.
Yes, sir, in joules.
In joule just convert, na? 1 kilowatt is equal to 1000 kilowatt, na?
Yes.
What is power? This is power. In joules कैसे आएगा?
Joule per sir.
Kilowatt hour you mean, right? You want kilowatt hour?
No, sir.
मिल गया? This is joules per. So this is 1000 joule per second.
हाँ sir, वही.
ये चाहिए ना?
Sir, next one कौन सा?
13. 38 आया क्या तुम्हारा आंसर? मिल गया, ठीक है। कहाँ स्टेप्स दिखाओ? हाँ। सॉल्व करो भाई, सॉल्व करो। क्या हुआ? नहीं समझा? क्यों? अपने को ये फॉर्मूला यूज करना है ना? देखो क्या करना है अपने को? So we have C1 M1 T1 minus C1 M1 T is equal to multiply. इसको ओपन कर दो ब्रैकेट में C2 M2 T minus C2 M2 T2. तुमको T निकालना है ना, तो इसको इधर ले लो और इसको इधर ले लो। ये हो गया C1 M1 T1 plus C2 M2 T2. This is equal to C2 M2 plus C1 M1 T. Therefore T equal to क्या आ गया? C1 M1 T1 plus C2 M2 T2 divided by C1 M1 plus C2 M2. सब्स्टिट्यूट करके सॉल्व करो। कैलकुलेशन में थोड़ी करने वाला हूं। ये ऐसे आ गया। C1 क्या दिया बताओ? What is C1? क्या है C1 बताओ? C1 क्या है? स्पेसिफिक हीट ऑफ क्या क्या है? दो सब्सटेंस क्या है? वाटर और क्या दो सब्सटेंस मिक्स किया है मैडम कैलोरीमीटर में? दो सब्सटेंस क्या डाला है? रीड द क्वेश्चन. Wait.
It's 4. Sir, the C is 4.
अरे क्वेश्चन पढ़ो. You're doing 11, right?
13.
Oh, it's 13.
Yes.
नहीं इसने 13.
हाँ. Sir,
I'm solving for her. I'm solving for her. She asked it out. And you understood it, right? 13 का डिस्कस नहीं कर रहा है. This is question 11. 13 का नेक्स्ट क्लास में डिस्कस करेंगे, ठीक है? You got 10, so 13 excuse, okay? Till 11, everybody okay?
Yes, sir.
No dinner without 38. घर जाके हाँ? Be honest. Okay. तीनों को नहीं आया? 11 किसी को नहीं आया ये टेबल पे? Now I was wondering where is my mark?
Sir, I got it.
You got the 13th also? Very good. So eat double. When is our next class now? Friday. Chalo, I'll see you on Friday.
प्रोफेशनल तो वैसा नहीं 3 साल का ट्रेनिंग है 3 साल का ऐसे